So in this video, we're going to talk about the improper integral, okay? And there are three cases that we need to be familiar with. However, one is more important than the others, okay? Because one have to do with the series, the others does not have to do with the series, okay? And so three cases are, if we have some sort of integral from b to positive infinity of f of x dx. This is case one. Okay, case two is that we have the integral from negative infinity now to b of f of x dx. So this is case 2. And we could also have the integral from negative infinity to positive infinity of f of x dx. And this is case 3. Okay, now I want to point out something here. This is the one that's most important. This has to do with the series, okay? Our series is never negative, okay? So we don't, okay? So this is the one that has to do with the series, okay? And so let's look at this one first. So what is the integral of, so what is the integral? What's the integral from 1 to positive infinity of 1 over x squared dx? Okay. What is it? Well, how we treat this is that we're going to take a limit as 1 approaches b. Okay, so I'm going to give you the general form of how we treat this. So what we do is that we replace b with positive infinity. And so what we do is that we take a limit as b approaches positive infinity. Take a limit as b approaches positive infinity of the integral of 1 to b of 1 over x squared dx. So this is how we rewrite this is how we take the integral in the improper integral in this form, okay? So again, we take a limit as we're going to approach, we're going to replace the positive infinity with b, and we take a limit as b approaches positive infinity of 1 to b, okay? And then the idea now becomes we just simply take the integral. So we take a limit as b approaches positive infinity of, well, what's the integral? Well, I could rewrite this. So this becomes 1 to b of x to the negative 2 dx, okay? So for integration purposes, all I did was just bring the x up and change my sign. Okay, and so we know that now if we take a limit as b approaches positive infinity, what's the integral of x to the negative 1? Well, we simply add 1 and divide by whatever the coefficient is. So the integral of this will become x to the negative 1. So we add 1 and then we divide by 1. So if we divide by 1, this is the same thing as multiplying by 1. So this is my integral. Okay. So my integral of x to the negative 2 is negative 1, negative x to the negative 1. And this is all integrated from 1 to b. Okay. And the idea now simply comes is that we plug in. And so we're going to take a limit now as b approaches positive infinity of negative b raised to the negative 1, okay, minus 1 raised to the negative 1. Okay, now let's be careful here. I had a negative in front of this, so I could factor it out of the integral. So I factor it out of the limit, so this becomes negative the limit as b approaches positive infinity of b raised to the negative 1 minus 1 raised to the negative 1. Okay, so this now becomes negative the limit as b approaches positive infinity. Well, negative b to negative 1 could also be written as b 1 over b minus, well, 1 to the negative 1 can also be written as 1 over 1. Okay, and the idea now simply becomes we could just plug in our infinity. So 1 over infinity, well, this eventually go to 0. And then we have a negative times a negative. So the integral in this case would actually be positive 1. Okay. So this is how we look at the integral. In fact, this is actually a test too. This is actually we could call this integral test, and if the limit exists, at some point, then we could prove that this series actually converges and diverges. And remember, this, we could also look at this as n is equal to 1 to positive infinity of 1 over x squared. And this is a p series. So we know p is equal to 2, which is greater than 1. So therefore, this converges. Okay. So we know by this converges. And the integral we got is 1. So again, that's how we use the integral test. And again, this is the most important improper integral. Again, okay, because it has to do with the series.